So we've got a rate function for people entering a line for an escalator, given as there is 44 blah 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 t over 100 cubed times 1 minus t over 300 to the 7th for 0 to 300, and it's 0. Nobody gets in line after 300 seconds. So first thing it wants us to figure out is how many people enter the line for the escalator during the time period from 0 to 300. That should be pretty straightforward. That should just be an integral from 0 to 300 of the rate function. And obviously, we're using the one that's actually valid for 0 to 300, not the one for greater than 300. And if you plug that into your calculator, the value that it gave out was 270. Does that sound good to everybody? Part A, pretty straightforward. 1 point for the correct setup, 1 point for the correct answer. Good or no?
Yeah.
Okay. All right. Now we were also given some more information. First, that as people get on the escalator, they exit the line at a constant rate of 0.7 of a person per second, and also that there was 20 people in line at the beginning. So for part B, we are asked during this time interval from 0 to 300, there's always people in line. How many people are in line at t equals 300? Well, that ought to then be the amount that we started with, which should be 20. We should add to that the number of people who enter the line, 270, and we should subtract from that 0.7 people for every second that leave the line. So 0.7 times 300, and that gives us 80. So at t equals 300, there are 80 people in the line, and that was also worth 2 points. 1 point if you did this consideration of the number of people leaving the line, and 1 point for the correct answer. A lot of people miss the point for the correct answer. They end up getting 60 instead of 80 because they forget that there was 20 people in line at time t equals 0. And a very important thing to check for when you're doing these rate questions are the initial condition. Like, is there an initial amount of whatever in the line or in the lake or whatever the situation is? Okay. Everybody good there with part B? All right, part C. For t greater than 300, at what is the first time that there are no people in line for the escalator? Well, that should be pretty straightforward. For part C, we've gone at least 300 seconds. And then after 300 seconds, nobody else enters. And so we just have to figure out how long it takes for those 80 people that are in line at t equals 300 to leave. Well, that ought to be 80 divided by 0.7 people per second, which should be 414.286 seconds later. And that was just 1 point for part C. Everybody good with that?
Yeah.
All right. I think A, B, and C were pretty straightforward. D got a little more difficult. So for 0 to 300, we want to know at what time t is the number of people in line at a minimum. And then we want to find to the nearest whole number the number of people in line at that time, and then we got to justify our answer. So we want to figure out when the number of people in the line is at a minimum. Well, let's write an equation to represent the number of the people in the line. Number of people in the line should be 20 people, because that's how many started. And then it should be plus an integral from 0 to whatever time period we're looking at between 0 and 300 of the rate at which they enter the line minus the rate at which they leave the line. Do y'all agree with that? Number of people in the line plus the integral of the rate they enter minus the rate they leave. That should be the total number of people in the line. And so if we want to find when this is at a minimum, we'll call this L. L prime, well, derivative of 20 is 0. And the derivative of the integral from 0 to t of r of x minus 0.7 ought to just be r of t minus 0.7. And to find when that's at a minimum, we figure out when it's equal to 0. And this is part of the reason why this is a calculator question. All you need to do is figure out when r of t equals 0.7. So you just graph your r of t function that was given to you, graph y equals 0.7 and look for the intersection point, or you just find the x-intercept of r of t minus 0.7. And that x-intercept, I think there was 2 of them. So they said t equals 33.013298 and t equals 166.574719. And we're only looking at on the interval from 0 to 300. So then to figure out the actual minimum, we just need to make a chart here and evaluate our function at all of the different time intervals. So at t equals 0, t equals 33.013, 166.575, and 300. And so you would just use your calculator, at least for the middle two here, you would just use your calculator to figure out the number of people in the line, 20 plus the integral from 0 to 33, plus that decimal of r minus 0.7, and then the same for 166. And at 0, you know that it's 20, because they told us that. And at 300, we already found out that there was 80 people in the line. And at 166, we found out that there was, if you did that integral, 158.070 people. And at 33, you found out that there was 3.803 people in the line. So we would say the min is at t equals 33.013 seconds. And we would say 4 people in line to the nearest whole person. Good or no?
So in the original equation where you have the integral from 0 to t of r of x minus 0.7, why wouldn't it be like 0.7x, where it's like then it's like a rate rather than just 0.7?
The rate is 0.7. The rate is not 0.7 times the number of seconds. The rate is just 0.7. So you could have written it this way: the integral from 0 to t of r of x dx minus 0.7x. Well, we would have said 0.7t because we're talking about in terms of time. Could have done that. I mean, that's what the integral of 0.7 is 0.7t. The rate is 0.7. The number of people leaving the line is 0.7 times t.
Okay.
Does that make sense?
Yeah.
Yeah, so
like the last part any differently, like, or do you have to set up like that table to figure it out?
you gotta set up the table. And I know somebody asked me this in the chat. Yeah, you gotta write out the table. You don't have to make it a table, but you gotta write out each of these values. You can't just graph it because they want to see your justification, so they want to see these values that you found to prove that it was at this lowest point here.
Okay, got it.
Yeah. That answer?
Yeah, thank you.
That, yeah, okay. I'm not, yeah, okay. Everyone's good?
What was the point breakdown on this last question?
Sorry, yeah, so for the last part of it, for part D, they gave you 1 point for putting R of t minus 0.7 equal to 0. That was 1 point. 1 point for identifying this value. 1 point for the answer. And 1 point for having a justification to show that it was the smallest value at 33.01. So one point was associated with just getting that 33 value. And then the rest of it was showing that the rest of those clearly couldn't be a minimum.
Okay, thanks.
Mm-hmm. Any other questions on that one? All right, I believe this was the next one that I asked you guys to look at, right?
Yeah.
Our bananas. Okay. So let's see here. In part A, well, okay. So first off, they're giving us an initial condition. So grocery store opens, got 50 pounds of bananas, and then customers are removing the bananas at this rate for 0 to 12 hours. And then after the store has been open for 3 hours, they start adding bananas at this rate. So from 3 to 12, they're adding bananas at this rate, which is, they're both measured in pounds per hour. And T in both F and G is measured in the number of hours after the store opened, right? So not just this one is not 0 to 9, but this one is for 2 from 3 to 12. So first thing it asks is how many pounds of bananas are removed from the display during the first 2 hours that the store is opened. So all you got to do is integrate 0 to 2 f of t dt, and that should come out to be 20.051. So that should have been pretty straightforward, and that's 2 points, 1 point for the integral and 1 point for the answer. Good or no?
Good.
Okay.
Good.
Part B then says find f prime of 7. Okay, well, finding f prime of 7 should be easy since this is a calculator question. F prime of 7 is equal to negative 8.120. All right, that's 1 point. And then using correct units, explain the meaning of f prime of 7 in the context of the problem. So f prime is the derivative of f, right? And f itself is the rate at which bananas are being removed from the display table. So f prime ought to be the rate of change of this rate, right? So since this is a negative value, we would say that at t equals 7, or 7 hours after the store opens, the rate of change of the rate bananas are being removed is decreasing at negative 8.120, and this is pounds per hour per hour. pounds per hour is your rate, and then we're making a second derivative of that. So that's by time again, pounds per hour. And so we say the rate of change at which the rate they're being removed. So they're being removed, the rate at which they're being removed is slowing down. They're being removed less quickly at t equals 7. Does that make sense?
If I just said that that number was the acceleration at which bananas are removed, would that get the point, or would I need like this more thorough explanation?
I think it's because they're saying in terms of like.
Because I gave the units and everything.
Yeah, maybe if you said I don't. I saying acceleration is a little bit off.
Okay.
Yeah, we don't usually use acceleration to talk about how quickly something is being removed from a table, you know, or the rate of change of the rate at which something is being removed from the table. You'd probably be okay, but try to stay away from a term like acceleration when you're not.
Well, isn't that what it is?
When
you take the derivative of a rate of change, you get the acceleration.
Yeah, but I mean, I still think you should try and stay away from the term acceleration unless you're talking about particle motion.
Okay.
Because acceleration is really, you know, it's the, you know, miles per hour, not, it's a distance per time period rather than a number of something per time period. They might give you the points for it, but I would hesitate to use the word acceleration.
Okay.
Any other questions on that one?
Was the whole thing just 1 point, or one for the right answer and one for the
sorry, one for the value and one for the explanation. All right, part C then says, is the number of pounds of bananas on the display table increasing or decreasing at t equals 5? I'm at a new page for this one. So the number of pounds of banana on the table, that should be the value of the integral of f minus the integral of g, but we want, is that increasing or decreasing? So really, we just want to know if f minus g is positive or negative when you plug in 5 to them. So part C is f of 5 minus g of 5 greater than or less than 0. Well, f of 5 minus g of 5 came out to be negative 2.263, which is less than 0, which tells us that the number of bananas on the table is decreasing at t equals 5. Any questions there on C? The breakdown for that is 1 point for considering f of 5 minus g of 5. Even if you got the wrong answer for f of 5 minus g of 5, still got a point for considering f of 5 minus g of 5. And then getting the right answer with the reason that it was less than 0 gives you the second point for that one.
If I did the same thing, but I didn't like give a value, and I saw like where it was decreasing and where it was increasing, and noticed that like at 5 it was decreasing, would that, like I did like a sign chart and everything, would that still get me the point?
If you did a sign chart and all of that, yeah, you should be fine. As long as you demonstrate why, then and your reasoning is sound, then should be fine. Yeah. But I mean, this is the simplest, quickest, easiest way to do it, I would say. All right, part D says how many pounds of bananas are on the display table at time t equals 8. So at t equals 8, we should have however many we started with, 50. And then plus the integral, wrong way, plus the integral from 3 to 8 of how many were added. So plus the integral of g of t from 3 to 8. And then should be then minus the integral from 0 to 8 of, I assume it was f of t dt, which is how many, the integral of the rate at which they're being removed. And that came out to be 23.347 pounds. And you got 2 points for having the right integrals and 1 point for the right answer, meaning that you didn't forget about your initial condition.
So why on the first integral did you go from 3 to 8?
Well, because that function is only valid for 3 to 12, and it specifically says after the store had been open 3 hours is when they started adding.
Okay, I missed that.
Yeah. Your reading comprehension skills will be on full display on these rate for your response questions. Like for real, they're gonna put stuff in here that might trick you if you don't read it carefully enough. So you gotta make sure that you read carefully. Everybody good there? Any questions on that? I think those are the only two that I asked you to do today. Is that right?
Yeah.
Okay. So I had forgotten that we were going to go over that multiple choice. I got the book right here in front of me. So we'll do that. You'll see that there are at least, I think I put at least 3 more on here. Yeah, there's at least 3 more. So these next 3, I don't think I posted them yet, but I will post them this afternoon. So one with a nice little chart here with a rate, another nice little rate one. So there's going to be one about water pumped into a tank, one about rainwater flowing through a drain pipe, and one about gravel being processed at a gravel processing plant. So I'll have you work on those 3 this weekend, and then I have a couple more to do in class on Monday as well. Did I say that we were going to do any multiple choice on Tuesday or no? Next Tuesday? If anybody have that in front of them?
The next check is 310 for differential equations. Is that on Wednesday or Tuesday?
Perfect, that's Wednesday. So we'll have the quiz on Tuesday on these rate free responses. And then on Wednesday, we'll go over that next multiple choice. So let's see here. I got to find definite integrals. Is that what we were looking at here?
Yeah.
Okay. So anybody have any questions on the definite integrals? Just throw them up in there in the chat and I'll start going through. 33. Somebody beat Alex to his long string of questions for one. So number 33 is asking us, 1 second here. 33 is saying the average value of y equals root 64 minus x squared on its domain is. And so if we're looking for the average value of something, we know that that's 1 over, and what's the domain of this function here?
Isn't it -8 to 8?
Should be -8 to 8. 8 minus -8. And we should know, what does this look like? This is just a semicircle, right, with a radius of 8. So it's 1 over 8 minus -8. And then the integral from -8 to 8 of root 64 minus x squared dx. It's just the mean value theorem, right? The average value of it is the mean value theorem. So 1 over b minus a times the integral from a to b of the function. But this function is one that you are going to have difficulty integrating on your own. So we have to think about, what does an integral mean? Well, an integral just means the area under the curve. Well, what's the area underneath this curve? It's pi times the radius squared. So the value of the integral is 64 pi, because we know that's the area underneath that curve. So it should just be 1/16 of 64 pi, which should be 4 pi. Choice D, it looks.
So why isn't it a full circle? Why only a semicircle? Because if you were to expand it out, wouldn't you just get y squared plus x squared equals 64?
When you take the square root, you either get positive or negative. We are only talking about the positive values of y here. This is positive square root. The bottom half of it is y equals negative square root 64 minus x squared.
Okay.
Anytime you just see a square root sign, that indicates to you that it is the principal square root, the positive square root. Everybody good there on 33? All right, 39 is the next one I got here. And if we don't finish these up, we'll finish them up on Monday, because I know we got the quiz retake that we're going to do at the end here, and I want to make sure I have enough time to post it. And I didn't mean to do that. Okay, insert new page. There we are. All right, 39 is that what I just said? Okay, 39. So for 39, we're finding the average value of another function here, which they just give us a graph. Looks something like this. They give us coordinates of these points. This is 2, 10. This is 5, 10. And so to find the average value of it, it's just 1 over b minus a times the integral from 0 to 5. We'll call this f of x dx. Well, the integral, just like the last one, we had to use the idea that the integral of this is the area underneath the curve. So the area underneath this curve is, it's either a trapezoid, if you want to call it a trapezoid, or it's a triangle and a rectangle. So whichever way you want to do it. We make it into a right triangle and a rectangle. We got a height of 10 and a width of 3, so that's 30. We got a base of 2 and a height of 10, so that ought to be 10. So it looks like it should be 1/5 of 40, which ought to be 8. Any questions there on 39? That good for 39? All right, next one is 29. Okay, 29 says we got the area of a shaded region in this figure. So here is 1, here's 2 and 3. And this is the function y equals 1 over x, and the shaded region is this region from 1 to 3. And so, let's see here. It says we know that the area of the shaded region, it says, is the natural log of 3. So if we approximate the natural log of 3 using a left Riemann approximation and a right Riemann approximation, that's I assume that's what they're meaning there. The capital L of 2 and capital R of 2 is not a notation that you will, that's a bad notation. But this is, I assume, meaning a left rectangular approximation and a right rectangular approximation. And so let me get another color here so that I can sort of write on here. So if we do a left rectangular approximation, the left rectangular approximation is going to give us a value of 1 plus 1/2 with the red, so that'd be 3/2. 3/2 has got to be greater than the natural log of 3. And if we did a right rectangular approximation, we're going to get 1/3, and we're going to get 1/2. And so natural log of 3 has got to be greater than 5/6. Natural log of 3 is just, as we said a minute ago, the integral from 1 to 3 of 1 over x. So whichever inequality matches that. Looks like that is E. So this notation is bad. On the AP test, they would have written out left rectangular approximation or right rectangular approximation. That's bad notation there, but that makes sense?
Yeah.
Okay. All right, next question, number 9. Maybe pages sticking together here. All right, so number 9 is an integral from, no, that's the wrong one, -3 to 3 of dx over 9 plus x squared. So we did some like this in the indefinite integrals, where it was almost like 1 plus x squared, but what did we do? We took out we factored out the 9 here. 9 times 1 plus x squared over 9. And we took the 1/9 out. And then this became dx over 1 plus x over 3 squared. And then we let u equal x over 3. du was 1/3 dx. So then I need to put in a 1/3. If I put in a 1/3 there, I got to put in a 3 outside. So I end up with 1/3 of the integral of du over 1 plus u squared. And then if u is x over 3, this becomes -1 and 1. And so this becomes 1/3 inverse tangent u, evaluated from -1 to 1. The inverse tangent of 1 is pi over 4 minus the inverse tangent of -1, which is -pi over 4, gives us 1/3 of pi over 2, which is pi over 6, which appears to be choice C. Any questions there on that one?
Nope.
Everyone's good. All right. 14. All right, 14 says if we let x equal 2 sine theta, then the integral from 1 to 2 of the square root of 4 minus x squared over x dx is equivalent to 2. And so basically they just want you to rewrite this by making this substitution where x is equal to 2 sine theta. And so in order to do that, we're going to need to first off figure out what dx can be replaced with. So dx will be replaced with 2 cosine theta d theta. And if x is 1, then we have 1 equals 2 sine theta, which tells us that sine theta equals 1/2, or theta would be pi over 6 for the lower limit. And if x is 2, 2 equals 2 sine theta means that sine theta equals 1. So theta would be pi over 2 for the upper limit. So we got pi over 6, we got pi over 2, we got square root of 4 minus 4 sine squared theta over 2 sine theta times dx, which is 2 cosine theta d theta. And then I assume, yeah, it looks like you got to simplify that out some. First off, these 2's will cancel. I can factor a 4 out of this, right? This becomes square root of 4 times square root of 1 minus sine squared theta. Square root of 4 is 2. 1 minus sine squared theta is cosine squared theta. And the square root of cosine squared theta is cosine theta. And we got another cosine theta. And then we got an over sine theta, d theta. And that ought to be enough to just take a look at it there. Looks like that's choice C. They pulled the 2 out and wrote it as cosine squared theta over sine theta. Good or no? Questions on 14, anybody?
Wait, so originally when they pretty much like gave a substitution. So with the dx, when you found 2 cosine theta d theta, what'd you use that for? The 2 cosine theta d theta? Did you just put that in as dx? I'm guessing you just straight up put it in. Okay.
Yep, because it's got all the answer choices have a d theta. This is kind of a stupid multiple choice question, so I wouldn't expect to see something like this. This is a technique that that we use in second semester calculus, so it's a BC or sorry, it's a Math 151 technique now, rather than a BC technique, in order to integrate stuff like this. It's called an inverse trig substitution. So something you learn in second semester calc, but should have been able to muddle your way through that, realizing that dx needed to turn into a d theta, and you could use the differential to figure that out, like we do with our u substitutions. So that's basically what it is. It's just a substitution to u sub, except that we're replacing the x's rather than replacing some other thing, some other expression in terms of x with u. We're replacing x with something in terms of theta. Same basic concept.
Okay.
All right, next one is 24. Oh, look, this one is just the same type of problem. Yeah, these are kind of stupid. I really wouldn't expect you to see one of these, but it's good practice for those of you that are going to take second semester of calc next year. Same thing here. So x is tangent theta, dx is secant squared theta d theta. And if x is 1, theta is pi over 4. And if x is root 3, theta is pi over 3, because you need to know those trig values. So you just get pi over 4 to pi over 3, square root 1 plus tangent squared theta times dx, which is secant squared theta d theta. 1 plus tangent squared is secant squared, and the square root of secant squared is secant. So this just becomes an integral from pi over 4 to pi over 3, secant times secant squared, or secant cubed theta d theta, which looks like that's choice C again there. Good. Any questions there on 24?
No.
All right, and then last one I've got in the chat, which is probably good timing here because we got to stop and do the the retake of the quiz. Number 42, we're looking at a graph that was given to us at this ended right there. So this was at 6, and this is the point 2, 4, and this is the point 0, 2. And so 42 asks us on which of the intervals is there a value of C for which f of C is the average value of f over the interval 0 to 6. And this is the function f. So we want to know, is there a value of C for which f of C is the average value of f? So f of C equals the average value of f. And so the average value of f is the integral from 0 to 6, 1 over 6 minus 0 times the integral from 0 to 6 of f of x. And this is just a trapezoid and a triangle to find the area there to find that integral. So this is 1/6 of the trapezoid has a base of 2 and a base of 4. So 2 plus 4 is 6. Divided by 2 is 3 times the height here is another 2, so that's 6 for the area of the trapezoid. And then the area of this triangle, this is x equals 2, so this is 4 times 4, 16, divided by 2 is 8. And so that tells us that the value of the average value of our function is 14/6 or 8/3. And so we want to know on which of the intervals there between 0 and 2, 2 and 4, and 4 and 6, do we get an actual value of 8/3? And so, well, the y value here is 2, which is less than 8/3, and we went up to a y value here of 4, which is more than 8/3. So there is one between 0 and 2. So yes to 1, which was 0 to 2. And then it says 2 to 4. And so 2 to 4, since this is just a straight line here, this is going to be the point 4, 2. So between 0 and 4, it looks like we should, or sorry, between 2 and 4, it looks like we should also go through there.
Isn't 14/6 7/3?
Yeah, 7/3. Arithmetic. Same concept though, more than 2. Sorry. 2, 4, so yes there. But on 3, which is 4 to 6, that is already below 2. So, so one.
Okay. So like the function goes up, hits it once, comes back down, hits it another time. Oh,
Yep.
I see. Okay.
But yeah, 14/6 is 7/3, not 8/3. I don't know why I said 8/3. Good question. All right, I think that's it. That's all we have time for. So you will do the next 3 problems, and what I will post these up on. Well, no, I'll post them up today. You'll do them over the weekend. 3 problems. We'll go over them on Monday. If there are any last-second other questions on the definite integrals, since I forgot to mention we were doing that today, we can answer those as well. We'll do some extra rate problems. We'll have the rate free response quiz on Tuesday, and then we will go over the next set of multiple choice on Wednesday.